The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, everybody. Good evening. My name's Warwick Rudd. I'm your host for today. In today's session at the DBA virtual group, we've got Ben Miller talking to us about TSQL best practices. I'll hand over to Ben shortly, but before I do, we just have some housekeeping to run through. So just to keep you informed on what's going on. There we go. We've got, if you weren't aware of it, we've got a Business Analytics Day coming up next month in San Diego, where you can learn some fantastic stuff around applied data science at this day. So if you haven't already registered, make sure that you do. It's a fantastic time for you to learn from some fantastic speakers at this event. You can get a discount. You can see here, 20% discount based on the time that you register and using the details on this slide. Now, Past Summit got coming up in the end of October. The rate goes up in a couple of days' time, so if you use this code VC15FPS6, then you can get a discount off your ticket at Past Summit. So make sure that you register, come along, and hopefully you'll see both Ben and I at Summit. This is just a call out for you. There are a number of virtual chapters that you can register and learn about. This just shows you the number that there are. Make sure that you go to the PASS website, find the appropriate virtual chapter that you're interested in, register, and you can get notifications around sessions just like today. At the moment, the PASS director elections are underway. If you're already a PASS member, make sure that you've completed all of your documentation and you'll be able to vote and be a part of what's happening with the PASS board. So this one here is showing us what we've got coming up for the PASS board and what we're kind of looking at. So make sure that you stay tuned with all of the emails and mail outs telling you about what's coming up. Here's a call out to some of our SQL Saturday events, both in North America and over in Europe. If you're in any of these areas, make sure that you register. Come along. We've got a couple in a couple of days' time and in a week's time. So we've got plenty of events for everybody. Why would you want to be a part of PASS and the local chapters? We've got the virtual chapter here today, but there's also actual local chapters that you can go along, meet other people, have face-to-face networking, have presentations from people just like Ben and myself. Make sure that you reach out to your local chapter leader, register, come along and support your local community. If you are interested in volunteering, then log into your PASS profile and you'll be able to select that you would like to be a volunteer, and you'll be reached out to on opportunities where you can assist. Just recently, overnight, or I think they might still be running at the moment, you've got 24 hours of PASS, where we've got 24 hours of sessions running and people are moderating those sessions. So feel free to do that and become more involved in the PASS community. So today's session will be recorded. It will be available up on the DBA virtual chapter archive site so that you can come back and see this recording at any point in time. Once again, stay connected, and I'll now hand over to Ben.
All right. Great. Thank you, Warwick. Hopefully everybody can see my screen.
Yes,
and we'll get started. So this session came about as I went around different clients and also at companies I worked at and found the little things that you take for granted. So really this is all about anywhere from beginner all the way to advanced people. And this is all about little things that happen in SQL Server that you might not think about happen, but need to be kept aware as you want performance or if you want to predict what you expect coming out of your query. So we'll get started. This is a little about me. I'll move on that. So the agenda today is going to be all about assignment statements. We're going to talk about those and how they work. It seems a little trivial, but you'll see how this applies to all the things you do every day because we all write select statements and every once in a while. Going to talk about schemas and qualifying objects, how important it is to recognize schemas as a first-class object and move out of the realm of SQL 2000, which I know many of you wish you would be able to all the time. Then case insensitivity and case sensitivity, it becomes important to understand how that plays into things. Even in case insensitive worlds, you still have to be aware of case sensitivity in some places. That will go into query plan nuances of things you need to understand about the query plan, and then we're going to talk about data types. That's probably one of the most important things you can do because we all take them very much for granted. And when you do that, you can open yourself up for some interesting performance things. And then we'll talk about identity and sequence. Now hopefully the demo gods will be happy today. I have had issues today getting my machines all running. Sent my main machine back, so we might have to improvise for the demos and make sure we have them go right. So let's talk about assignment statements first. The first part of assignment statements deal with ways we can use assignment to variables, setting it equal to a value. So this isn't going to all be about select statements like selecting from a table, but there will be a piece that we will want to look at for selecting values from a table, but more into variables. So the two ways that are most common people know about, set is a way you can set a variable equal to a value. The one big deal about this thing is that you can only do one at a time. So you can imagine if you had 50 variables that you needed to set a value to, then you would have a 50 set statements in your code. That may or may not be a big deal to some, but it is a single operation for each set statement. So if you want your CPU and your SQL Server doing that in one cycle per set statement, then you can do that. The select statement, on the other hand, allows you to select multiple variables equal to values in a normal select statement. So you would be able to do the select separated by commas and not have a table. The other thing that set allows you to do is to select values into variables from table columns, which becomes pretty important when you start doing more and more TSQL in stored procs or functions to get values out of tables that you've already put together. So we're going to see this in demo and how the nuance works with understanding this. The other little thing about set is that I'm sure many of you have seen the set statement that says set variable equal to, and then in parentheses you have a select statement that selects a value out of a table. And that is the only way you can get a table column value into a variable if you're using set. It looks a little ugly, but it does work. There's some things we'll show you about the set statement that are really cool. The next way to do that is a declare statement. So in 2008 and above, you're allowed to declare your variable with its type and set it equal to a value at the same time. And those can be strung together by commas as well. So you could declare 10 variables with their types and then set them equal to a value right off the bat. So that could be considered maybe a constant type value or something like that. But in 2008, that becomes a viable way to assign a value to a variable. And now the last one is very interesting because it's been years now, but when I first started giving this presentation, it was new to me. I had never heard of setting a value into a variable from an update statement. But we're going to see in demo how that works and what to expect. So really this This slide and the demo associated with slide is really all about behavior. I learned long ago that sometimes it's less interesting to know how people say they should, or say you should do something, because opinion is there, but there really isn't one way to do something that is the right way in every scenario. So I tended to focus on behavior, so that if you understand the behavior, you can make your decision based on your experience and expertise, and decide how you would use that statement if you knew how it behaved. So the big deal about assignment statements is we'd all like to think that when we write our code, we never have to come back and review it or even refactor it. Heaven forbid we are the amazing coder and never refactor a thing, right? That would be beautiful if everybody wrote code that way, that never had to be refactored. You never had to look at it again. It just runs. But we know that's not true. That's all a nice fictitious thing. So in the end, it really becomes you spend time developing, and then you come back later and you have to support it and maintain it. So I would recommend in this behavioral slide to say that your consistency in how you do it is going to help maintain costs later. If you have declare statements all throughout a 2,000 line stored proc, heaven forbid you have a 2,000 line stored proc, but I've seen them. They exist in the field, I promise. Having that many statements strung all the way through the code makes it very hard to tell whether you've declared it or whether it's been assigned or not. So typically, if you behave in a, I would say, in a designed way, you've already decided up front how you're going to do style, and you follow that style. When you come back to edit it, or anybody else who is under your employee comes back to edit it, you'll have a better shot at maintaining it a lot more cost effective. Now let's talk about schemas. So back in 2000, which it seems like a really long time ago, I was at Microsoft in SQL Server support, and we saw this a lot when people upgraded from SQL 7 to SQL 2000, and as they prepared to get their code underway, default schema became a pretty big deal. And by default, the default schema became DBO if you were a DB owner. If you weren't, then your default schema would be your username. So anybody that used SQL authentication, anybody that used Windows authentication, the username would become your login name. And then your default schema would be your username by default if you didn't change it. So if you're a DBO, it automatically just let you have DBO, and that's all good. In 2005, things changed where schemas became a first-class citizen, where you had the create schema syntax and allowed you to create your own schema, put your object in that schema, and then you could grant permissions on that schema or on that object specifically. And that gave birth to a new era where the idea of selecting from a table without a schema qualification became very common because it defaulted to DBO before. I'm going to blame Oracle because that's fun to do. Oracle has the concept of your login is your schema, and you own that schema, so the login logs in, and you're already in that schema, so what's the point with putting a schema name in front of your object? So they would have all the PL SQL just be select from table name without any schema, so it's really kind of handy. We don't live in that world. We actually can have a login that doesn't own the schema they log in and use. As you can see with DBO, that is the default schema for everything, and if you don't ever create a new schema, all your tables will be created in DBO schema unless you're not a DBO, and then they'll be created under your default schema, which could be DBO if it was assigned. So the idea is that every cycle you save, if you make SQL Server think about which schema it's in, it's going to take the route of looking in your default schema first. If it doesn't find the object, whether it be a stored proc, table, anything, it will look in your default schema first. If it doesn't find it, then it will look in DBO. And the reality is if you start using schemas or you have users with not the default schema of DBO, you end up having SQL to have to derive where it should look for that table. And anytime you make SQL do that, you burn a cycle. If you want your cycles to be spent doing that instead of executing code, then that's your choice in letting the behavior of SQL be that. So a cycle saved is a cycle earned. We want to make sure SQL is focused on the right things. And the reality for me is that if I know that that table's in DBO, then I should be using select from table, which is DBO dot object name. The objects actually do have a 4-part name. It's part of the SQL standard, where the server is the first one, which typically we do not specify except for those who are using linked servers. And then there's the database. If you're in the database, the objects in that database, you don't need to specify that because you're in the context of that database. And then the last two, I always, when I advise people who are coding T-SQL, I advise them to always use at least the 2 parts. So schema.object, whether it's DBO or not, whether I'm a DBO or whether that user's a DBO or not, things can change down the road. And if you then change that user, then you can have a lot of breakage if your code's not coded to that spec. So I typically go 2 parts. And context is always king when you're dealing with SQL Server. So let's go hop out to demo here real quick. And we will look at the idea of our, let's go into it. Oh, my little thing's in the way. Just a second. Let me move there we go. Let's go into my demo 1 for assignment statements. And what I've done basically is I've created a table, and I won't give away the table yet until we get done with this. But basically, I'm declaring an ID and a name, and I want to set the ID equals 1. So that works pretty well with SQL, and it basically works. So that's really nice. I'm going to use a select statement now to do ID equals 1 and name equals Ben, and that works as well. So we execute that, and it doesn't balk at all, and the names go in there. Now, this is the syntax I was telling you about when you look at the ID equals to a something from a table. Now, this is the only way in the ANSI set statement to get a value from a table into a ID. But watch what happens here. Let's go up and do my little execute here. We get an error here on this set statement because there happens to be 2 rows in this test table, which I did not tell you. The rule in ANSI is that every time you use a subquery in a select statement or in a set statement, it can only return 1 value, or it is an error. So in this case, it threw an error saying subquery return more than 1 value. This is not permitted. So the important thing to remember is you either do a top 1 or you make sure there's only 1 possible value that can come back. And I didn't declare my variable because it's up here. So now this one will work and it will succeed. So the important thing to remember is that when you're doing this, make sure that you're getting what you expect. Now this is a little red herring that will give away the next demo, but that's okay. We're going to select from test table to show you what's in there. And I guess I'm out of memory. That's fantastic. Did I tell you that things were going to go awesome today? Yeah, I'm going to exit out of this window and go back in. Oh, beautiful. So let's go back in. And we'll just have fun after there. There we go. Yeah, this is how my day has gone. It's been fantastic. But that's okay. We will get through this. Here we go. Oh, no, that's not good. I'm going to have to use a different version of Studio. That's great. Yeah, we're going to go back here again and use a different version. This is going to be not nice. Let's go back into here. Let's see if we can use this one. Come on. Nice. Okay, here we go. Now let's go back into our demos here. Connect here. Make sure we have our databases. Yep, we indeed do. Open up our little code. All right. And if it's all nice, it'll open them up. Okay, here we go. All right, so let's go back in once we get all of them loaded. There we go. All right, let's go back in. All right, so now we go back into our thing and we notice that we do have a demo DB and we select from test table. And we notice we have two rows. So that's why the subquery was blowing up, is because I had 2 rows. Now, we saw the 2 rows and the fields are Ben and George. That's the rows. Now the idea is, in an interactive session, it would be easy to have people tell me what they expected to come out of name. So we're going to declare a variable called name, and we're going to assign the name variable equal to the field value from test table. Now set would blow up. We saw that set blew up when we tried to do this set ID because it returned more than one value, and it should have a problem. But this select guy, he's really nice, and he allows you to blow yourself away here, and you get George back. Now the idea is that there were Ben and George in there, and I wonder why George came back and not Ben. We didn't put an order by, so the order is at the whim of SQL Server. But I did get a value back, but it didn't throw an error. So the idea is that whenever you use a select and you put a value from a column into a variable, and you do not have a unique row coming back, so you don't get only one row, what you get is the last row. And the last row value is George if we did a select without a where clause. So selecting, I get Ben and George, and we saw I got George back in the name when I did that. So now we're going to do a select that tells the idea that we are going to select name equals field this time with an order by clause. So let's do that and then run this code here. George and Ben are the fields that we expect back in order descending, so G before B, and then I get Ben back. So I did indeed get the last row coming back. Now you say, well, that's not a really big deal because there were only 2 rows, and you're absolutely right. This demo came from a process that had been running for 4 years. No lie. 4 years it ran with no order by, with no top one, and it was returning the last row in the row set and setting it equal to this into this variable. And this automated process ran for 4 years with no flaw until we updated the SQL Server with a certain patch that somehow either changed the index or changed something where SQL Server used a different index when it optimized the query. And all of a sudden it came back with a different value and the automation broke. Now try to troubleshoot that one. That's really fun. So we want to be careful of that and make sure that we either do order bys, or the other solution would be select top 1 and I get back the 1, and then if I did that, then I would obviously get George instead of Ben because I said top 1 and it would get me the first row. So I can limit it that way, but imagine doing that with a 1,000,000 row table, or even a 10,000 row table, or even a 1,000 row result. You're going to assign that variable that many times as it goes through the rows, and it'll land on the last one. A cycle saved is a cycle earned. So I could be specific in this case and say, give me where the field equals Ben, and obviously this is contrived. But the second side of it is I could have an ID column here where I say where ID is 1, give me the field. And so in reality, it's nice to think that this is a contrived example, but the reality is that you will have this behavior that you know how it works. Now go apply it to your situation. And I wanted to show you this as well. So select field from test table. If I had it in a select clause, we've all done subqueries to get the one column back. And that throws an error as well because it is a subquery, even in the select clause. So it's not just in a set clause that it happens that way. And this is the other example we had where we have 2 rows, we execute, and the subquery throws an error. So just be careful when assignment statements and select statements, when you start doing that, it starts getting a little weird. Now we already know about the declare, so I'm not really going to belabor the declare because it's really just syntax where I would just say equals something. And that's simple. I can do that easy. I'm going to show you the update clause before we go back to slide. And the update clause says update this table and set the name equal to the field column name, because that's not what it's called, so I better have created that table. I did. Good. So I'm updating this test table and I'm setting the name variable equal to the name column, the description variable equal to the description column, and then I'm changing the name column into equal Benji instead of Ben. So the idea is that I'm doing an update statement, and the question is, what do you think the values will be as soon as I run this update statement? So we'll run it, and the real question is, do I get the before picture or do I get the after picture? And the behavior is I actually get the before picture because this is Ben the best and then Benji the best and George of the jungle. So I've changed the 2 fields, but I got the before values. The reason is because it hasn't yet committed. When I'm updating, it hasn't yet committed this thing, so I get them as they are. So that's a behavior you'll want to do. I don't ever use this syntax in production, but some people do. Microsoft did in ASP.NET State server, so you have to be really careful about that. I don't think that this demo will work because my database table and my logins got erased. But the idea, I'll just quickly walk you through it. I have 2 tables. One's created in the DBO schema and one's created in another schema called DBA. And I don't have the schemas created because I had to hurry and get this thing done. But basically the idea is if I said select star from Ben or table, whatever the table is, and I didn't specify the schema, it would use my default schema. This test login has the default schema of DBA, and so I would get the DBA schema here, which I would expect to get the DBO potentially. If I reverted that back and I was my DBO user again, then I would get from here, I would get DBO, or I could be explicit. So be explicit when you do your coding, at least to 2 parts, the schema and the table object. All right, the next thing to worry about. So a lot of people today use case-insensitive sort orders on their servers. Typically they just install it default. At least in the US, I've seen that being very common. I haven't seen a whole lot of people installing it for binary or case-sensitive. Every once in a while I'll see a case-sensitive database, but not a whole lot, especially not on the server. But back in the day, I was a SQL 4 guy, and I got my start consulting and stuff in SQL 6.0 and 6.5, installing Great Plains Dynamic software. And the default for them was recommended as a collation of the server to be binary. And the reason was for speed. So in their software at that point in time, everything you typed in the fields would all go uppercase. It just mimicked mainframe stuff where everything was uppercase, and that was the way it was. So in those collations, you get speed from binary searches. They can use a binary search to get to the data really fast. When you go into the case-insensitive realm, it has to look for both small a and large and capital A, and that's not very helpful. So you want to be careful when you define your collations that they really relate to how you want the server to sort your data. So the idea of an uppercase in kanji in Japan really doesn't exist. There really isn't an uppercase kanji character. So those, when you put a Japanese collation on your text column, it really is going to govern how you order by, not really how you search, because typically your stored procs are going to be named in English. So that's not really the issue. But the real issue is when you have a case sensitive and you're using English characters or something that understands case. So back in the day, we had to tear the server down when the customer wanted to use a case insensitive sort order, because you don't get to change the server collation except when you install SQL. You can change collations for a database, but if you've ever done it, it is a pain in the butt, because every text column, every nvarchar, and every varchar all assumes the sort order of the database that gets created. And if you don't specify a collation for the creation of the database, you get the default server sort order or server collation. And then if you don't specify a collation for your nvarchars or varchars, you get the default database collation. Then when you change the collation of the database, it then sticks all the collations as that collation. So when you script it out, it scripts out the collation with your text column. So be careful when you start looking at collations in server sort order. You can take it for granted that it's case insensitive, but here's the idea of what I've seen in the field. Whenever you develop, it's really easy to have a table that has an uppercase and a lowercase, so when you read it, it looks great. But then you go into code and you see select from table name that's all lowercase or all uppercase, or a mix of not even close to what is defined, and columns as well. I recommend to everybody that as they go into a new project, I would not go back and retrofit everything and refactor. But if you're developing new projects, it is really helpful when you develop your code to use products that will let you use the proper definition case, so that if the company ever decided to move to a server sort order that's different than case insensitive, your code would still work. So that's that for case insensitivity there. Now the other extension of case sensitivity comes to the query plan cache. So in the query plan cache, or we might hear it called the procedure cache, the procedure cache is case sensitive. Everything that goes in, regardless of what goes in, all the text that goes in is very much case sensitive. It hashes the query, and then it can look it up to see if the hash is the same. If you change one letter, add one space, it will be a totally different query to the optimizer or to the query plan cache or the procedure cache. That is very important to understand, because you could pollute your cache really quickly with ad hoc queries of just highlighting it differently. Then the problem comes in single-use queries. The reality is you have so many queries you can stuff in procedure cache, and you have so many bytes, and the bytes don't even compare to how much bytes you have available to the buffer pool. Buffer pool is the lion's share of the amount of RAM it uses, and the query cache kind of gets a percentage of that based on how much RAM you have. So be careful, and you want to protect that resource pretty heavily. So in 2008, they introduced a new setting called Optimize for Ad Hoc Workloads, that basically when you set that setting, it comes off by default, even in 2016. I haven't checked 2017, but I believe it is off there as well. But the recommendation behavior-wise is that you enable it always until you find a reason to disable it. The main places where people disable this is in data warehouse loads, where one query optimization, the query might be pretty complex, and you don't want the optimizer working on that again and getting a different plan potentially. So turn this on. It creates a stub for every first query that runs of about 300 bytes, and then the second time it sees the same exact query, it optimizes it and puts a full plan in cache. And hashing is the way it uses to identify it. So again, if you add a space, if you add a carriage return line feed, if you change the case of a select of one letter to capital S instead of a small, it is a completely different query to the plan cache. Now the next thing that I really like to have people understand is data types. So it's really common to see people go, well, what difference does it make if I use an nvarchar as opposed to a varchar? They're the same, right? They're all strings. And the reality is that is not true. I used to have somebody come up in a session and say, can you compare an apple and an orange? And we'll just say a lemon versus a lime. And the reality is that you cannot compare a lemon to a lime. The only thing you can do is compare its attributes. You can't compare it to the other because they're not the same thing. They may be fruits, but that's a type. It's not them, it's not the fruit itself, it's actually a type of fruit. I can compare, well, one's yellow and one's green. Okay, that's an attribute of that fruit. It is not the fruit. So when you think about nvarchar and varchar, you can think of a varchar is a 1 byte thing. You can put an A in there and it's 1 byte. If you do an nvarchar and put an A in there, it's actually 2 bytes because nvarchar is Unicode and it has 2 bytes per every character. And so if you put a English text thing inside an nvarchar, you're burning as many bytes as you have characters because that second byte will never be used. And that will be a bad waste of space. But the comparison is the problem. Not necessarily that you've wasted space because you could determine that you have mixed and you could have characters that are longer. So the idea of here is that you have a varchar and an nvarchar and they are not the same. They look the same. The only character difference is n in the nvarchar, but the one has 2 bytes, the other has 1. You could never compare 2 to 1. You'd have to take off the 1 and make them all equal to 1s. And that is where we get implicit converts. So the comparison of greater than, less than, or equal to requires the optimizer or requires the SQL Server execution engine to have exactly alike data types. And that's why you'll see warnings in the query plans where you have a varchar compared to an nvarchar, because it will want to escalate one to the other. So I've put a link in the deck that just says this is the data type precedence chart, and it will always escalate from low to high. So if you have an nvarchar comparing it to an int, it will always try to convert the nvarchar to an int and then do the compare. So if you like convert implicits in the query plans, then you can keep doing that. But that's a really big deal of comparing the same data types. Now I'll throw something in. I haven't seen a lot of adverse effect, but it's the same as doing a different type. If you compare an nvarchar 50 to an nvarchar 100, you are comparing 2 different types because one's longer than the other, and one could have 51 characters and one could have 50. And so you could get a red herring in there and not get what you expect if you were trying to compare, because it could only compare the 50 to the 100. And you'd have to it would have to chop off the other ones. So be careful with data types. They can be friendly, but they can also be really painful. And the last thing in the thing before we go back to the demos and do all the rest of the demos is the identity and sequence. Today, it's really common to use identity columns. Sequence has been with us since 2012. Sequence is an external entity where you can get the next value for my sequence, and you can use it in a default for a int column. The big deal about that is that if you have an identity column, you can't directly insert the table into the table without turning identity insert on, and then you turn it off. The big deal about identity is that for a long time, people use add-at identity to get the value. And the reality is, I won't have a demo for this, but the behavior of this is that it's a global variable. So whatever the last identity was in your scope, it pulls that identity back. So the real demo that you can try for yourself is to put a trigger on a table, put an insert trigger on a table, insert into that, and in the trigger, you want to insert a row into another table that has an identity column on it. And when you get the add-at identity after the insert, you will get the other table's identity value back. It's a global variable. There's the bug. So in this scope identity, it scopes it to your direct scope. So that's the way you get back your identity values, using scope identity rather than added identity. Even today in modern code, I still see added identity, and it makes me cry. So let's go and spend the last time doing the demos, and hopefully it will all be friendly, more than it has been friendly. All right, so I've created a table, and I'm hoping that we will see that the table has a lot of rows in it. If it doesn't, I'll cry again. But it has 1,063,000 rows. That's quite a few rows. It does have a unique clustered index on account number, and I'm going to set statistics on and no count on so we can see what it does. And I'm going to declare an ID to be a type of int, and I'm going to set that value equal to this. This could be just as well a parameter into a stored proc or anything like that. So I want this guy right here. And we know that the account number is unique, so I'm good with getting this distributor ID from the account number, and I'm going to see what my query plan looks like. So I've set statistics IO on. I'm going to set my query plan on, and we're going to run this query. And I should expect back one row. And we would expect, because I did a star, that it will bring back the clustered. It will use the clustered row. And I did get back one row, which that's great. My messages say that I scanned 9 and logical reads of 13,552 to get my one row. And let's take a look at this guy and see what it's telling us that it did. Maybe. There we go. It did a table scan of accounts. And why does it not have my clustered key? Let me go back and make sure I have a clustered key on it. Maybe it didn't get created. Okay, so we'll let that run for a second. Come on, just finish. Oh, I left this on. Okay, well, we see that it's going to scan the table to get me my clustered index. All right, so now I'm going to do it again, and we're going to see, it's just it's the same thing. A table scan and a clustered index scan is the same thing. A few less rows because it compacted them a little bit with the clustered index, but it does say clustered index scan, and it used parallelism on my laptop, which is like, wow, really? It's local, it's SSD, still use that. But then we look at this little thing here, and I don't have zoom in on here, I'm sorry, but basically it convert implicit. The account number was converted implicit to an int. Well, what you didn't see was that the table was created and the account number was actually an nvarchar 100. So what could bite you here is that I did an int here and did a where clause equals, and this guy's an nvarchar 100. It would try to convert all of these values to an int first and then do a compare in this one. So I could do something like this, and again, this is contrived, but I want to compare nvarchar 100 to nvarchar 100 and see what my results look like. So I'm going to get this parameter in my stored proc. I came in and said, oh, hey, this is an nvarchar 100, so I'm going to run it that way, and let's see what our query plan looks like here. So I still get back to one row. It was fairly fast. We didn't really have to worry about the speed. But look at this scan count of 0 instead of 9 and 3 reads. And basically those 3 reads are the root, the intermediate page, and the leaf page. Done. I'm in. And the query plan says clustered index seek with no parallelism and in the bucket. So like data types become really, really, really important when we start doing things with data. This is really contrived in that I'm only ever using one table, and sometimes we only have one table we deal with. But when you start joining tables and you just assume that all the tables have the ID the same, even if different teams developed them, you ought to think twice, because I've been in an environment where that is actually not the case, and it gets to be really interesting when you go find out that someone's comparing an int to a float or a nvarchar to an int. And they really don't know it because they thought that everything was an int or a big int. and that is not the case. So just be careful when you start looking at how you query and how you do your where clauses. It can bite you really quickly. All right, so this is the standard disclaimer. Do not try this in prod. You know, don't free proc cache in prod because that's really kind of dangerous. If I were to look at my cache plans, it shows me that I just have a few, one compiled one, and that was just the query I just ran. Size in bytes, 458,000 bytes. That was pretty big. Let's do a basic query here and select from test table, and I got to be in my database first because it will work better if I do. And now I get my table, and let's do another query of the same table. You'll already be able to see what's going on, and then let's do one more query to see what happens there. And now we will select the cache plans and find out what is in our cache. And we have, okay, that's a bad view. Here's our queries right here. I will get a better view up here. So let's do this guy. And now we come over and we see that we have it did some views. So we don't worry about those. We're going to look at the bottom ones. So select star from test table. We know about that one. Then we have select star from test table again. They look kind of the same, don't they? I mean, from this view, it looks pretty close to the same. The difference of this query, each one of them has 32,768 bytes in the plan. This one has 58 bytes in the plan, and this one has 56. Oh, there's an extra space. But why the two? Why 2 bytes instead of 1? The reality is that everything inside the optimization world of the query cache or plan cache is all N varchar. It's all Unicode because it has to be able to deal with any character that has 2 bytes. So you will get 56 bytes instead of 28, and you will get 59 bytes or 58 bytes instead of 29. So just know that it's 2 bytes each character, and I did add one more character in here. There was an extra space which added that. The plans were still 32,768, but that's 32K, right? That's 32,000 bytes, not small. So that's not really great for our plan cache. And then the last one, there's another one up here, so right here. So that's 58 bytes as well, with the same 32,768. But it didn't use the same plan. These are 3 distinct plans. So we got to be careful how we do these things. So now, oh, I guess I did this a little differently. What we want to do now is we want to go into our instance, and we want to change our little guy to be advanced, and we want to change our optimize for ad hoc workloads to be true. Now that flushed cache, okay, so that flushed cache here, we'll do a select, and I should only see me. Oh, nope, it did not flush cache. It only changed the bit setting. So if you do anything with the backstop and with the processor stuff, the set cost threshold, then it will flush cache. I guess the optimize for ad hoc workloads does not flush cache, so we're going to flush it for it, just because we want to. And it's not prod, so we're good. Now I want to run these queries again, so let's run these guys again. Query, 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 and query. Now I'm going to run this one twice because I told you that you could get a full plan when you executed it twice. And sure enough, here's my first query, here's my second query, and here's my third query. So 384 bytes instead of 32,768, 384 and 32,768. 58, 56, and 58, so they're still, but notice this one says it's a compiled plan. And this one's a compiled plan stub and a stub. So beware that when you use case differences in your query, that's why I love stored procs and I love views, because they are static, right, until I change them. The code executes, the case is all the same, it's all happy. It's a really good thing. And I guess I do have a thing here for, yes I do. So let's just do that, and we'll create these tables just for fun. And we'll do the demo here for that. So let's execute that. Oh, yeah, it does have a cow when you start doing things that are more out of order. Create table has to be the first, or create trigger has to be the first command, just like create view. We'll truncate these tables even though they're probably empty anyway. And then we will change the seeding for table 9 to be 100,000 and the seeding for table 10 to be 200,000. So we can actually get an idea of what's going on. So if I insert values into table 9, I'm going to insert the value of name into there. It has an identity column, so it's going to insert a row and put an identity. If I select add identity here, I'm going to just select all of this. I'm going to insert this, and I'm going to select first add identity and then scope identity. And then add it gets me 200,000, and my scope gets me 100,000. So that's the first red herring that you're going to find is if you have a trigger, it's going to get you the identity value of the latest table because it's a global variable. This guy will scope it to your statement that you created, not any statement that happens afterwards in a other thing. Now, here's the other weird thing that happens when you turn on the set identity insert. This is something that very few people talk about, but I'm going to set identity insert for table 10 on. And then I'm going to insert into my table. Now remember, it started at 200,000. Right now it's at 200,001 because I inserted one row. But I'm going to insert my thing and set it to, I'm going to set my value to be 200,010 so that I don't have to worry about conflicting with anything that's already in there because it has a primary key on it. So I'm going to insert this guy in here, and I'm going to select scope identity. And I get 200,010. Now that may seem weird because I turned identity insert on and I wanted my scope identity. But what this just did, if I were to insert into this table and then set it off again, I'll turn it off. Now we're going to select from the table. Let's do the select from the table. Let's select from DBO table 10, just to show you what's in there now. So now we have 200,000, 200,010, and 5. Now any guesses as to, I think we already turned it off, right? Yes, we did. So any guesses as to what we get back for the identity when I insert into here? 200,000, whoa, I missed the values of 200,000, 2, 3, 4, 5, 6, 7, 8, 9, and now it reset my identity to 200,011. And that is the reason why you have to be very careful about these set identity inserts if you're not going to use sequences, is because it will reset your identity when you insert a row greater than the current identity. You'll skip those nine identities because you said you're going to put it into 200,010. So beware when you use identities and you set identity insert on to insert data into the table, you could have a pretty interesting deal because now I have a nice gap between 200,000 and 2010. I have 5 and then 200,011. So you can get really weird things, and there's no way, easy way for SQL. I mean, SQL can't do it. You can do it, but there's no easy way to go back and fill in that gap. There are ways that you can do it yourself, but it's really crazy to do. So I would recommend that you think about the ideas of what you can do with keeping the identity or sequences. Sequences are a little easier, except you have to modify the sequence. So you have to have a user that's able to modify the sequence to put it back to 200,001. And then when it hits 200,010 or 9, you have to jump it ahead. So it's kind of crazy, but be careful with identities. They're fun, but they can be dangerous. All right, so the last thing about one of the things I've seen is that people that I've seen develop SQL have used old technology because they used to be on 2000 or they used to be on 2005 and that feature wasn't available. So when you start thinking about performance or coding, a lot of people will code to be compatible with all engines, and you just got to call a spade a spade. The more generic code you write, the slower it will be. So when you get to the point where you're going to store blobs, test out file streams, see if it's faster to stream it rather than to put it in a binary max column. It can be faster if you use file streams with things greater than a meg. It's slower if you use anything less than 750K. It's faster to put it in a blob. inside the column. So just test things out with new features. There's a lot of new features that came out in 2016 that give you a leg up. Test them out, see what happens. But it's a lot better to use modern features and code to complement the engine that you have to your credit rather than trying to code to the generic side. Hopefully that was helpful. I think we're at the end of time. We're almost at the end of time. We have a few minutes for questions. Feel free to fire away or not if you just want to go to bed.
Okay, so at the moment, yeah, feel free to whack through any quick questions. We've got a couple of minutes, as Ben said. So if we don't get any questions in the next couple of minutes, then we'll say thank you to Ben. We'll say thank you to everybody. So does anybody have any questions that they would like to ask?
I must have explained it so super good.
Everybody's saying all good, thanks.
Great. That's awesome.
Well, as mentioned, this session has been recorded. It will be placed up onto the DBA virtual chapter archive site, probably in a couple of days' time. So feel free, if you need to, come back, review this session. Make sure that you register for any upcoming sessions for the DBA virtual chapter. I also host the DBA fundamentals chapter in, or pretty much in this time zone, in an hour's time. That will be in a few weeks. So hopefully I might see you on that session.
And I will update I will put the slides and demos scripts up on dbaduck.com. There's a presentations link. You'll find them there. Feel free to go grab them after. I will make sure that all of the creation statements are in there for that one demo for the table with the permissions to DBO and DBA are there embedded so that you get those scripts. Otherwise, I hope to see you at the summit. I have a half-day session on PowerShell for the DBA and tips and tricks, so hopefully we'll see you there. And there's going to be a great lineup this year for PASS, so hopefully we'll see you all there.
All right. Thank you, Ben. Thank you, everybody.
Thank you.
Have a good afternoon. Have a good night.
Thanks.